Well, good morning, good afternoon, or good evening. We are Team 13 here in MEEN 601 for the fall 2020 semester, giving our final presentation over our designed grocery sanitization system. We came up with this need after looking around us and really wanting to solve something related to COVID-19. So we developed the following need statement. A need exists for a safe and efficient system to sanitize and disinfect groceries during the grocery shopping process. From this statement and after some customer interviews, we found the following key kind of engineering design requirements. The first of which being that our system should kill at least 99.999% of the COVID-19 virus. This is in step with EPA regulations for disinfectants. Secondly, our system shall process at least 15 items per minute to help to kind of keep with the efficiency standards for these grocery store employees as our end users. And lastly, the system shall be able to process any grocery item less than 1 foot by 2 feet by 1.5 feet, just to again accommodate most grocery items.
From this phase, we moved into ideation and functional decomposition. For the functional analysis, we constructed a functional block diagram with all the various subfunctions that would be involved in the general process. The two main subfunctions here are applying the sanitization and transporting the groceries themselves. But all of the subfunctions were brought into the morphological matrix from which we selected specific concepts to create broader general concepts. Ultimately, we went with this ultimate concept. The two main takeaways from those two subfunctions I mentioned are the powered rollers to transport the groceries and the spray nozzles to apply a chemical sanitizer. We went with those two in particular because they work really well in conjunction with each other. The spray nozzles have the ability to apply sanitizer through the powered rollers to be able to access the bottom surfaces of the groceries, which was something that a lot of the other options did not have.
Looking at our design specifications, here in the top left, you see our drive system. So we have a head drive belt-driven powered roller system controlled by the speed control motor on the top right. The roller assembly there in the middle, it's a 1/2 inch diameter spaced 1 inch apart. And this ensures that each item will be in contact with at least 3 rollers at a time to avoid any tipping or any items maybe falling through the cracks between the rollers. In the bottom left, we have our nozzle assemblies. These come out at a 43-degree spray angle. We have 6 of these placed throughout the spray chamber. That spray chamber you find there in the bottom center is made out of sheet metal with PVC shielding to help reduce the weight. And again, kind of keep a lot of the spray disinfectant contained within the chamber. And then in the bottom right, we have our proximity sensor. This is a photoelectric sensor that will detect when an item is entering the chamber in order to turn on the spray system to mitigate any excessive use of power. When designing, we wanted to keep in focus the assembly and usability after discussing that with our end user. For assembly, we chose a highly elastic drive belt and a neoprene rubber that will allow the person assembling the system to simply slip that over the drive pulleys. We wanted to utilize commercial off-the-shelf parts as much as possible. And then in our bolted connections, this is, again, just kind of drives home the assembly process. For usability, we created adjustable height stands that will allow for kind of an easier, more convenient use of the system. Again, the speed control motor eliminates the need for the grocery store employee to understand power and torque and some of these higher engineering concepts. And then lastly, we designed the system to have all of our engineering components on one side of the assembly.
With something as serious as COVID, we also went in to run a risk analysis, in this case in the form of a failure modes and effects analysis. From this, we identified 3 critical failure modes, as you can see in bold. To address one specifically, we realized that the pump we had selected to apply the sanitizer had a risk of burning itself out when running dry, and our current iteration of the product had no way of notifying the operator when the fluid levels were low. So we realized that in order to lower that risk priority number, that sort of functionality was something we needed to add for a future iteration of the product. And lastly, just to justify some of our design choices, the choice to apply the sanitization in the form of a chemical sanitizer was primarily related to the speed and energy efficiency of that. The sanitizer we specifically selected has a contact time of just 15 seconds to kill COVID, which is far faster than other methods like UV sanitization. For transporting the groceries, the powered rollers offered that sort of benefit alongside the spray nozzles. unlike something like a conveyor belt as is traditionally used with groceries. And then lastly, we wanted to import the electricity via a separate power line into a normal outlet rather than hardwiring the system into a cash register, just to limit the amount of time needed to implement a system and get it up and running. So with that, we just want to thank you for watching our presentation, and we hope you have a good day.